building a better Bay Area, moving forward, finding solutions. This is ABC 7 News.
Hi there, I'm Kristen Z. You're watching Getting Answers live on ABC 7. But first, can scientists predict an earthquake? Yes, like forecasting. It's a bombshell question that's coming up after a new study found some earthquakes in California may be detectable 1 to 3 days before they strike. Joining us live now are Dan Schneider and Tom Blyer, both of Quakefinder, a Palo Alto-based company aiming to find ways to forecast major earthquakes. Gentlemen, thanks for joining us.
Thanks, Christian.
All right, whoever wants to take
here.
the answer, just go for it. Look, your company collaborated with the applied science team at Google Research and did a study, and it was, pardon the pun, potentially seismic. What did you find there?
Well, what this study found is that in magnetic time series data, magnetic recordings that we've made with our network, I've got some examples of our stations behind us, we find that we are able to distinguish the magnetic recordings that are 24 to 72 hours before an earthquake from recordings that were made earlier. So that is a first step in being able to say that there are magnetic disturbances that are detectable before earthquakes.
Can I just ask you, how much data do you have? Like, we're talking about how far back, how many earthquakes?
Well, Tom's been there since the start of the array, but Quakefinder has been recording data since at least 2005. We've got almost 100 terabytes of magnetic time series recordings.
All right, sorry for the layman. That's a lot, right? And also for the layman, what is magnetic field energy?
So if you think about it, our instruments are sort of like a microphone, but they listen to the magnetic field instead of listening to audio recordings. And so we are recording these magnetometers, with these magnetometers, magnetic signals that are happening all the time. And these fluctuations the magnetic field is always wiggling and always vibrating. And what we see is that those vibrations get a little bit more intense in that period, 24 to 72 hours prior.
And does it get more and more intense as you got closer to the event?
So what this study shows is that when we're looking at that window is more intense by a very small amount, but detectable than other 48-hour periods. And future research will have to go into really trying to correlate if there's also an increase with magnitude. So as magnitude goes up, do the signals get louder? That's still an open question.
Can you explain yet what is causing that, the signals getting louder?
Well,
we don't know yet.
We do know that the magnetometer signals are basically caused by underground currents. Now, what actually causes the underground currents along the faults is up for maybe a little bit of a controversial explanation. But regardless, what we're trying to do is show that there is an effect that our magnetometers can pick up. Any kind of a current that changes will generate a moving magnetic field.
Are these sensors along all the major fault lines in the Bay Area or California? Is that how we have measured them before the quakes happened?
Yes, we started with just a few sensors around the Bay Area, and that started in about 2000 to 2005. But then we built really professional grade sensors that over the period of 15 years, we essentially installed these 3-axis magnetometers every 20 miles along the major faults, like the San Andreas, the Calaveras, the Hayward Fault, all the way from Eureka in Northern California, all the way down to the Mexican border.
Okay, I know it's going to be a while before you can get to where you are now to being able to really forecast, but it's very enticing because you're talking about noticing a difference 1 to 3 days before. And 1 to 3 days before is huge when it comes to earthquake warning, isn't it?
It's substantial, yeah. We have right now, either you have long-term 30-year probabilities from, like, say, produced by the USGS that tell you, in the next 30 years, we expect a magnitude 6 or greater with almost a 90% probability. And in the short term, you've got quake alert or shake alert that once the once the shaking starts, you can get an alert out to people before it reaches them. This is something in between. This is a short-term concept that would allow humans to actually take action that we haven't been able to take before. Now, with what we have in our study right now, there's not yet enough specificity in the data to be able to issue forecasts now, but it sure points in the direction that it could actually be possible.
The U.S. Geological Survey states plainly on its website that there is no way to predict a major earthquake, in no way in the near future. And some of their scientists are on record being kind of skeptical about this possible approach. How do you respond to that or look at that?
I think there's a saying that the data really tells the story. People can make claims that they can detect animal behavior or lightning or whatever, but if you have the data, if you systematically collected the data over 15 years, and you've got at least 24 earthquakes greater than magnitude 4.5, and the statistical evidence is shown now by not only the latest paper in JGR, but also the one that Dan wrote in 2019, two different groups of people looking at the same data with different algorithms, coming up with the same answer. That's amazing.
Do you both think that's beyond the realm of randomness?
That's exactly what this paper shows, is that we collaborated with a team from Google Applied Science. And so Google brought their expertise with a top-notch statistician and their expertise with machine learning and deep data analysis. And we scrubbed this data, and they set up a very, very rigorous study to show that the changes that we're seeing are unlikely to be random. And so that is a statistical baseline to say it's evidence that there really is something going on in the magnetic field. Now, yes, there's more work to be done to get to the point where we'd say it's conclusive, but it definitely points in the direction that there's something happening.
Yeah, because for true prediction and forecasting, I think USGS says you have to define the three elements of date and time, location, and magnitude, right? I know it's really asking you to look into the future, but how can you see the usage of magnetic field energy data to getting to the point where you can pinpoint those three elements?
Well, I think where we go from here is knowing that there is something going on, knowing that there is something to be found, and putting more and more energy, more researchers, more effort into investigating this is going to help tease out these signals and help us learn how to find them more reliably and get to the point where we can find them reliably enough to actually start issuing meaningful forecasts with them.
Are you going to need government partnership to make that happen?
We would love to partner with the U.S. government. We'd love to partner with anyone that wants to take this research to the next level.
All right, Dan Schneider and Tom Blyer of Quakefinder, thank you both so much for coming on the show today.
You're welcome. Thank you.